Okay, in this problem we're going to focus on making the maximum use of the TI-84 calculator when we're doing Newton's method. So we're given the equation or the function x cubed plus 4x minus 3 equals 0. Actually, that's an equation. And we want to approximate its root using Newton's method. And it tells us to start out with an initial approximation of x sub 1 equals 1. So Newton's method, if we skip down here, tells us that um, x sub 2 will equal the x sub 1 value minus f of x sub 1 divided by the derivative evaluated at x sub 1. So right here I've calculated the derivative, and it would be 3x squared plus 4. If I plug 1 into that, I get f prime of 1 is 7. And if I plug 1 into the original function, I get f of 1 is equal to 2. So I plug in those values, so I end up with x sub 1, which is 1 here, minus f prime, or f of 1 divided by f prime of 1, so 1 minus 2/7. And I'm going to wait just a second and go over to the calculator and evaluate that, but let's look at what x sub 3 would be. That would be the x sub 2 that I'm getting ready to calculate minus f of x sub 2 divided by f prime of x sub 2. And the issue here is it tells me to do the third approximation, and it just says to give 4 decimal places. Now that doesn't mean that this particular answer is going to be the root approximated correctly to 4 decimal places. It just said do x3. So the issue is going to be I'm going to get a decimal for 1 minus 2/7, and if I round that too far, then I'm not going to get the right answer when I do x sub 3. If they want 4 decimal places, then you should not round that to less than 4 decimal places. In fact, I would use 5 or 6 decimal places to be on the safe side. However, you can use the calculator and you won't have to round, and that's what I'm getting ready to show you. Okay, so I had 1 minus 2 divided by 7. And this is going to be x2, x sub 2. So that's my approximation for x sub 2. So I can store it in here and then use it later. That's one method, or the even slicker way is to go over here to your y equals screen, and you'll notice in y1 I have the function x cubed plus 4x minus 3, and in y2 I have its derivative. And then I can go back to the home screen and I can simply type out Newton's law, which is whatever x you're dealing with minus the function evaluated at that. So I have the function in y1. So if I go over here to vars and choose y vars and function, and it's in y1, so y1 of x. And I have just stored my x sub 2 in there, so this is going to calculate x sub 3 for me because I stored x sub 2 as x. And notice I didn't have to round it off. It's using the whole value. So divided by, and then the derivative I stored over here in my y equals screen. See, the derivative is y2. So then I come back over here and go to vars again because it won't let you type the y with the subscripts. So we have to get the vars this way. And this time I want y2 because that's where my derivative is, evaluated at the current x value I'm working on. So look at that. That is Newton's method. X sub whatever, in this case, x sub 2 minus the function evaluated at x sub 2 divided by its derivative evaluated at x sub 2. I hit enter. There's my x sub 3. And in this particular problem, it said find x sub 3 and round it to 4 decimal places. So 0.6742, and we're done. But just to show you how easy this is, now that's my x3. Look how easy it is to calculate x4. I just store x3 now as x. And then I hit second and enter, and that brings up where I had, oops, wait a minute. I didn't hit enter after I stored. So store the answer as x and hit enter, or it won't be in there. And then do second enter, and that's going to bring your last thing. That's not what I want. I want the line before it. So hit second enter again. There's Newton's equation. You don't have to type it in again. And then hit enter, and there's x sub 4. Now if I want x sub 5, then I'm going to store that value, my x sub 4, into x. Then recall that line where I typed in Newton's equation there and hit enter, and now I've got my next value. And you can see now that this actually is the root approximated to 6 decimal places because my last two x values that I calculated are correct to 6 decimals, 0.673593.